Okay, so what we're going to do here is a quick review of Lesson 6 from Unit 6, Trapezoids and Kites, and to help prepare for the Unit 6 test. There's a few definitions here. Trapezoid being a quadrilateral with one pair of parallel sides. The parallel sides are called bases, the non-parallel sides are called legs, and the two angles that share a base of a trapezoid are called base angles. So you have two pairs of base angles, one at the top and one at the bottom. And an isosceles trapezoid is a trapezoid where you have legs that are congruent, not bases, legs. That means the diagonal pieces going up here, A, B, and C, D. And we're going to go through some theorems here real quickly. First of all, Theorem 619, if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So when you're finding out the measures of different angles in a trapezoid, keep this in mind that if it is a trapezoid, isosceles trapezoid, with those two sides equal, then that will also play over into the fact that the base angles are congruent. Okay, so here's an example problem. They tell you in this problem that the what you have is an isosceles trapezoid, so you know right off we have the legs are congruent, and based on the previous theorem we also know that the base angles are congruent. So they're asking in this particular problem, what are the measures of angle DE and F? Well, we know automatically that angle F is going to be 65 because of what we were just talking about. But how do we know what the other angles are? Well, if you recall back in the earlier chapters, if we have two parallel lines, which would be two bases, if we extend them like this, and then we look at this CD as being a transversal, then all the properties of two parallel lines cut by a transversal would hold. And one of them is that same side interior angles are congruent. So look at the interior angle CDE and then the interior angle DCF. They are going to be supplementary. Did I say congruent? I meant to say supplementary. So this one and this one will add together to be 180. So that allows us to figure out what D is, because I just subtract 65 from 180 to get 115. Then I can go back to the previous theorem that says the base angles of an isosceles trapezoid are congruent, so that I can show that angle E and angle D are congruent to each other. And that makes them equal 115. Okay, so that's a good example of how to handle that kind of problem with isosceles trapezoids. It's a good idea to work some examples, so we will we'll go over some I'll show you some examples and have you work those separately. Okay, so before we continue on into some of the other concepts, take a look at these problems here, 7 through 12. And work as many of these as you can. I'm going to come back, have you pause the recording now and work some of these problems, and then I'll come back and give you the answers so that you can check yourself. Okay, so we want to find the measures of the numbered angles. So for number 7, angle 1 is 77 degrees. Angle 2 is 103 degrees, and angle 3 is also 103 degrees. Okay? So if you don't want to know the rest of the answers, you can pause it right now. Meanwhile, I'm just going to go ahead and continue on. Number 8, angle 1 is 69 degrees. Angle 2 is also 69, and angle 3 is 111. The number 9 measure of angle 1 is 49. Measure of angle 2 is 131, and the measure of angle 3 is 131. Number 10 measure of angle 1 is 105. Angle 2 is 75, and angle 3 is 75. Number 11 measure of angle 1 is 115, as is angle 2, and angle 3 is 65. Number 12, angle 1 and 2 are both 120, and angle 3 is 60. Okay, we're going to review the other two theorems that are in this chapter, or this lesson. First of all, theorem 620, if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So we've got another thing that comes out of being an isosceles trapezoid, and that is that the diagonals, like AC and BD here, are congruent. We're also going to talk about the mid-segments of the trapezoid. We already know that a mid-segment of a triangle is the line that joins the midpoints of two of the sides. So when mid-segment of a trapezoid is basically going to join the mid-segments, or the midpoints of the trapezoid's legs. So the trapezoid mid-segment theorem basically states that if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases, and the length of the mid-segment is half the sum of the lengths of the bases. Or in other words, it's the average of the two bases. So these two things are going to be important when you're solving problems with trapezoids and their mid-segments. Okay, so let's work an example problem here. We have QR being the mid-segment of trapezoid LMNP, which means Q is at the midpoint of L and P, and R is the midpoint of the segment MN. We want to find out the value of X. Or in other words, we want to find out, first of all, the length of the mid-segment in terms of X. So we're going to use the formula 1/2 LM plus PN. Substitute for LM is the expression 4x minus 10. For PN, it's 8. Then when we take these and simplify them, we'll end up with 1/2 4x minus 2 on the right side, and on the left side, x plus 2 is the expression for the mid-segment, and we know those are going to be equal. So after all is said and done and we shake everything out, we end up with x is equal to 3, which is what we are looking for. Now if it asked for the length of the mid-segment, then we would just substitute 3 in place of x to get 5. But in this case, it's only asking for what x is. Okay, so we're going to look at 3 sample problems that you can work. 13, 14, and 15 here. It says to find EF in each trapezoid. So we're finding the mid-segment of each trapezoid. Not just finding x. We have to find x first, but finding the actual EF, which is the length of that mid-segment of those trapezoids. So pause it here, work these problems, and then come back and check your answers. Okay, so for number 13, the answer is 9. For number 14, the answer is 11. And for number 15, the answer is 9. So hopefully you got all those right, or at least you can go back and check to see what you did wrong. Okay, so the last section in this lesson has to do with kites. We have to define what a kite actually is. A kite is a quadrilateral. It has 4 sides, and in this case 2 pairs of consecutive sides are congruent, but no opposite sides are congruent. So for example, this side and this side, these are consecutive sides. They're not opposite. They're consecutive. They are congruent, as are these other consecutive sides. So that defines what a kite is. Now we're going to talk a little bit about a condition of a kite, and that is if we know we have a kite, if a quadrilateral is a kite, then its diagonals are perpendicular. The diagonals would be coming from here and then here, and they are perpendicular to each other. That's theorem 6-22. Okay, so the next section here has to do with proving that. We won't worry about that right now. We just want to know how to work a problem using kites. So let's look at this example problem 4. We know that quadrilateral DEFG is a kite. We want to know the measures of angles 1, 2, and 3. Well, because we already know by the previous theorem that the diagonals of a kite are perpendicular, then we already know that angle 1 has to be 90 degrees. In the diagram, they already give you that angle GDF is 52, so by the triangle sum theorem, we add 90 and 52 together, then subtract that from 180. We will get the measure of angle 2, and it turns out to be 38 degrees. Okay, so the last thing we need to find out is what's the measure of angle 3. We know that triangle DEF, which is this one right here, is congruent to DGF because of side, side, side. The middle side here is common to both of them, so it's congruent to itself. But then by the definition of a kite, the other sides are congruent. So we have congruent triangles, and because corresponding parts of congruent triangles are congruent, then angle GDF has to be congruent to angle EDF. So angle 3 has to be 52 as well. Okay, so use this example to work some practice problems. Okay, here's some of the practice problems. Work as many of these as you feel you need. And I'm going to go ahead and pause your recording here at this point, and then come back and check your answers. Okay, so angle 1 is 90, and number 16, and angle 2 is 68. In number 17, angle 1 is 90, angle 2 is 45, and angle 3 is 45. Number 18, angle 1 is 108. Angle 2 is 108. Come down here to number 19, angle 1 is 90. Angle 2 is 26. And angle 3 is 90. And there are the rest of your correct answers for number 20 and 21. And what we have here is just a summary of the relationships among quadrilaterals. We start off with a quadrilateral, which could be any figure with 4 sides. If two of the pairs of sides are congruent, then we call it a parallelogram. I'm sorry, 2 pairs of parallel sides is a parallelogram. Then out of the parallelograms we have rectangles and rhombuses, and if it's a rectangle and a rhombus, then we call it a square, and some of the various other relationships. So study this, make sure you kind of understand it, and you should do well. Thank you for your attention.